Hello guys, good morning to all of you. Today in this session we will be discussing error analysis, propagation of errors. Okay, and this particular topic is very important from electronics and experimental method. This particular topic is coming under experimental methods, and you can expect 5 marks question or sometimes 3.5 marks questions are also set from this particular topic. Now, without any further ado, let's start. But before that, let's check whether everything is all right. Then we can start our session. Audio is all clear? Start our session. Okay. Good morning to all of you. So we'll start with the definition of error. So from here, experimental methods starts. Error, it is defined as the difference between the observed or calculated value and the actual value or true value. The difference between them is known as the error. Error in measurements arises due to various reasons and due to uncertainties, and analyzing these narrow errors is known as error analysis. Simple thing. Now, what kind of errors we generally see? So there are mainly two types. One is systematic error, another one is the random error. Systematic error caused by flaws in the equipment or experimental designs. Somewhere may be weak, some other screws may not be tight, or some other experimental design limitation may be there. So that causes systematic error. These errors are consistent and predictable. Okay, and you can have little bit of calculation to avoid that. Random error, on the other hand, occurs due to unpredictable variations in measurement. These errors can be estimated by repeating measurements multiple times. One beautiful example has been showcased here. While measuring the oscillation period of a pendulum with a stopwatch, you are keeping everything same. You are using the same stopwatch, you are using the same pendulum, you are using the same thread. Still, you are getting little bit different oscillating time. So values may vary around a mean value. This deviation from this mean is a random error. I hope you understood the different types of errors. Now, there are two terms in this experimental analysis section. Good morning, Murli. Accuracy and precision. What do you understand by accuracy and what do you understand by precision? Accuracy of an experiment is a measure of how close the result of the experiment is to the true value, how close it is. What is precision? Precision is the repeatability of the measurement result without reference to its agreement with the true value. It may be closer to the true value, or it may be away from the true value. But precision, we can have an instrument has a good precision if you get similar result, very identical results from that instrument, then we can say the results are precise. On the other hand, if you see that the results are closer to the accurate value, then we can say the accuracy of the instrument is good. Now, the distinction between the accuracy and precision is illustrated by this following figure representing hits on the bull's eye. So, bull's eye is the actual value, we can say true value. Now, three figures have been shown. So, what are you seeing here? This, like if you get a value here, so this is your true value. Okay. Now, you see in the first figure, you are getting the values at some radius. So, radius is constant, but it is far away from the true value. Here you see most of the values are near the bull's eye. Few values are scattered. And here you see most of the values is around the true value. So, can you give an estimate? High precision and high accuracy. If you talk about the first figure, what it has? It has high accuracy or high precision? Can you tell me? Look, if I talk about for each figure, let's say accuracy. Accuracy is high or low, precision high or low. You have to just tell me this. For the first figure, high precision, high precision, this is high. Precision is high, accuracy is low. Next, high accuracy and low precision. Next, bandage, you are going good. Third one, tell me. High accuracy, high precision. Is it clear to everyone the difference between accuracy and precision? The same thing has been explained here in first figure. We have high precision, low accuracy. High precision, then low accuracy, high accuracy, low precision, high accuracy, high precision. It is obvious that we must consider the accuracy and precision simultaneously for any experiment. It would be a waste of time and energy to determine a result with precision if you know that the result would be highly inaccurate. Obviously, if all of your results are coming, if the accuracy is low, what is the if the accuracy is low, what is the point of having a high precision? What is desired? The third figure is desired. It should be highly accurate and highly precise, right? Conversely, a result cannot be considered to be extremely accurate if the precision is low. So, high accuracy and high precision, these two things are expected from a particular instrument. Okay, these are some basic stuffs. Let's talk about some numerical factor. We can give the heading of data interpretation and analysis. We have already talked about these things in mathematical methods topic while discussing the statistics. So, let us say if we make n number of measurements, so each measurement will give us some value. Let us label them. The first measurement is x1, second measurement is x2, third measurement is x3, and in this way the nth measurement is xn. Then the sum of the measurements, what will be the sum of the measurements? Sum of these measurements will be sum over I is equals to 1 to capital N xi. So you can represent it in this way. Is equivalent to writing x1 plus x2 plus x3 and so on up to xn. Let us say if you want to calculate the mean of the data. What is mean? Mean is represented by mu, or sometimes it is represented by x average, x bar or x average. This is equals to sum of all the results divided by total number of measurements. So this is the mean value of the data. I is equals to 1 to n. If we talk about a deviation, so you can imagine a picture to understand it better. Let us say this represents the mean value. Let us say we are talking about this value as x. Now the data points, it may be like this, scattered in this way. Let us say this is your x1, x2, x3, x4, x5, x6, x7, x8 and so on. Now this difference between the data and the average value, that is the standard, that is a deviation, standard deviation also you can see. So it may be positive, it may be negative, right? So deviation, or it is also called standard deviation. Deviation of the data points it is the difference between the data. Deviation, let us say we are denoting it by di, constant data, minus the average. So you can see it may be more than the average, sometimes it may be less than the average. So it may be positive or it can also be negative. Now if I talk about average deviation, what is average deviation? Average deviation we can get by just dividing it by the number of data points, okay, taking the sum of the total deviation. Each deviation is xi minus x average, okay. If you take all the deviations from I equals to 1 to n, let us say, then if you just divide by the total number of data points, you get the average deviation. Now there is a term called variance. Variance is denoted by sigma square. Sigma square is this square by n. This xi minus x average square, its average, I is equals to 1 to n, divided by n. This is variance, and its standard deviation is just the square root of this variance. Look, deviation is for each data point. Standard deviation is a single quantity defined for all the data points. Standard deviation is sigma, so you just need to remember it is square root of the variance. So it will become sum over I is equals to 1 to n xi minus x average square divided by n. Any question till now? Let me give you a question. This question came in December 2018. The standard deviation of the following set of data is nearest to. So what you have to find out? Standard deviation. Standard deviation means sigma, square root of sigma square, square root of sum over I is equals to 1 to n xi minus x average whole square divided by, this is what you have to find out. N is how much? N is, you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 data sets, 10 data points are there, so n is equals to 10. So you can start with making a table. Just make a table. Like this. You will write the value of x, then xi minus x average, and here you can write xi minus x average whole square. Here you will write xi actually. This is xi minus x average. Here you can write xi minus x average whole square. So before that you need to calculate the x average. What is x average? Do it quickly, guys. This is 10, again 10, 2 times 9.9, 9.8, 9.9 3 times, 9.8, 9.9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 9.9 x average, 9.9. Yeah, okay. Let's calculate this. X average. X average is equals to sum over I 1 to 10. Xi divided by 10. Okay. Divided by 10 you can do. Or you can simply write, if you want to write a formula, don't mention the limit. Sum over I xi divided by n. You have to add all these values. 10, 10, 9.9, 9.9, 9.8. How much? 99 you will get. 1 point missing, 1, 1, 2, 2 to 4, 5, 6, 7, 8. Are you getting 99? 99 by 10. So 8, 10. So 1 is missing. So 100 minus 1, 99. Okay. So that is why you are getting 9.9. Even without using calculator, you can do it. Xi minus x average. So each value you need to subtract each value from 9.9. So xi minus x average. So 10 minus 9.9, you will get it 0.1. Here you will get it 0.1. Okay. Now 9.9 minus 9.9, so 0, 0, 0, 0, 0, 0, again 0. So what you are left with? 9.8. 9.8, so minus 0.1. Square. So this is 0.01, 0.01, 0 is 0. This is 0.01 with a plus, 0.01. This is, so total you can see 0.04. Sum over I xi minus x average square. You can see 1, 2, 3, 4. So 4 times 0.01, 0.04. So sigma value, which is equals to square root of I is equals to 1 to 10 xi minus x average whole square divided by 10. Square root of 0.04 we have already calculated, divided by 10. So what value are you getting? 0.04 divided by 10. So 2 by 1000, approximately 0.063, which is closest to 0.07. Yes, Vantage. B. Look, you have to divide by 10, okay? Don't make it like after getting 0.04, don't click on 0.04. Okay, let's move on. Error propagation. Ajay has not come today. Ajay, are you present? Error propagation. Let's say we have quantities, they are related. If we have quantities x, y, z, they are related. It may be more than that, are directly measured counts, directly measured counts or related variables. For which we know, let's say sigma x, sigma y, sigma z, dot dot dot. If there are many other variables, then it will keep on going. These are the related variable. Then the standard deviation for any quantity is derived from these counts. Can be calculated as let's say, okay, sigma u square is equals to del u by del x whole square, sigma x square, del u by del y whole square, sigma y square, del u by del z whole square, sigma z square, where this u, which is a function of x, y, z, represents, if it is a variable of, if u is a quantity or function of more than 3 variables x, y, z, or some other variables are there, so then there will be similar terms in the addition. This represents the derived quantity. Derived quantity. This equation 1 is known as the error propagation formula. You can imagine it in this way, that x, y, z are the quantities and sigma x, sigma y, sigma z are the errors. Error of measurement of error of measuring, error in the measurement of x, y, and z. We can imagine it in this way. that sigma x, sigma y, sigma z dot 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 are the errors in the measurement of x, y, z and so on, right. Now, this is the overall formula. All other formulas will be derived from it. This is the actual formula. You need to remember this. This is the error propagation formula. Let us apply this concept to sum or difference. Let us say if some derived quantity is given as the sum or difference of the other quantities. Sum or difference. What it says, let us say u is a quantity which is may be defined as x plus y, or it may be defined as x minus y. Then what is the value of del u by del x? You require del u by del x, right? Del u by del x is equals to 1. And what is del u by del y? It is again 1. So, what will be the value of sigma u square? So, you need the formula of this thing. It is a function of x and y. So, del u by del x square sigma x square plus del u by del y square sigma y square. So, del u by del x square is equals to 1 square, so sigma x square. This is also 1. So, this is sigma y square. And this is valid for both u is equals to x plus y or u equals to x minus y. Okay, no, for this one there is some slight mistake we have done. You see, del u by del x equals to 1 and del u by del x equals to 1. This is for the first one. For the difference, you see, although del u by del x is equals to 1, but del u by del y is equals to minus 1. Okay. But when you take square of them, you get it like this. So, for both of them, you will get this result. So, sigma u is nothing but square root of sigma x square plus sigma y. Is it clear or not? So, for both sum and difference, you get the same formula of error propagation. Let me give you a problem, then do it. This came in June 2017. The experimentally measured values of the variables x and y are 2 plus minus 0.05 and 3 plus minus 0.02 respectively. What is the error in the calculated value of z equals to 3y minus 2x from the measurements? Can you do this problem? So, you can imagine it in this way. Z is a function of x, y, and you can move forward. Sigma z square is equals to sigma z square is equals to sigma z by sigma x square, sigma x square, sigma del z by del y whole square, sigma y whole square. Now what is del z by del x? Let's calculate that. Hello, good morning. हाँ, हाँ, किसका एप्लीकेशन? तो वो बनाना नहीं होगा? हाँ हाँ, सुजन जी तो सारे चीज प्रोसेस किए। हम्म। 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 अच्छा। हाँ। ठीक है। हम्म। हम्म। वही वही, ये तो है। हम्म। ठीक है। ठीक, ओके। Okay, you got the answer, guys. Option A. This 0.05, it is the value of sigma x, and this is the value of x, you can say. This is the value of y, this is the value of error in measuring y, sigma y. We have just put the value and you got 0.12. Okay. So this was the first case we discussed, sum or difference. I hope this is understood. Let's go for the second one. The process is similar. You just need to follow the same procedure. Let's say next case, multiplication or division by a constant. What you gonna do if you have multiplication or division by a constant? Let's say we're taking two cases. Firstly, if u is given as ax, so a scalar has been multiplied with the variable, where let's say a is a constant. In such scenario, what you gonna do? So first of all, del u by del x, this is a. So what will be your sigma u? So you have only one quantity, so there is no point of writing sigma u square equal to del u by del x square sigma square. You can directly write del u by del x, or you can just follow the procedure, a square sigma x square. So sigma u is equals to a times sigma x. Okay. Now, if some scalar is divided, u is equals to, let's say, x upon b. B is a scalar, b is a constant. In that case, if you calculate del u by del x, again it is 1 by b. In a similar fashion, sigma u will be sigma x upon. No issue in this. Now, if overall in general, let's say the third case, multiplication or division. Multiplication or division of variable. In that case, what you're going to do? For an example, if u is given to you, the product of two variables x, y. So, for this you have to calculate individually. Let's say del u by del x will be y, del u by del y will be x. Okay. So, sigma u square, we are not writing del u by del x square sigma x square. So, we are just directly writing y square sigma x square plus x square sigma y square. I hope you understand. Now, you can make little bit of modification here. You see, u square is equals to x square y square, right? So, if you divide both sides by x square y square, so sigma u square divided by x square y square, you can write sigma u by u whole square equals to sigma x by x whole square plus sigma y by y whole square. This formula is very important. This will be used when you are asked to calculate percentage error, okay, na? Fractional error. So, sigma u by u. So, you can see sigma x by x. So, this is a fractional error in x, sigma y by y. Okay. So, this is also a very important formula. Let's go for its b case above. Don't have space here, so we are writing it here, case b. Let's say if u is given to you as x by y, so what will be del u by del x? It will be 1 upon y. What will be del u by del y? Minus x upon y square. Clear? So, what is sigma u square? So, del u by del x square, so 1 by y square into sigma x square plus del u by del y whole square, so minus x by y square whole square sigma y. Now, if you do the same thing, if you let's say divide by x square by y square, so multiplying by y square by x square, similar thing, right? So, we can write sigma u by u whole square is equals to, so multiplying by y square by x square. So, sigma x by x whole square, and this is again sigma y by y whole square. Can you write it? So, sometimes they ask you what is the error in the measurement of u, percentage error. In that case, you can take square root of this sigma x by x whole square plus sigma y by y. Most of the question comes from this particular case in your examination. Okay. Sigma u by u, square root of sigma x by x whole square, sigma y by y. Any question till now? Anyone? Harry, vantage point, Murli, everything all right? Everything clear? These are very simple topic. Simple and enjoyable topic. Let me give you one problem. Okay, do this. Both the data points and a linear fit to the current versus voltage of a resistor are shown in the graph below. I versus V has been shown to you. If the error in the slope is 1.255 into 10 to the minus 3 ohm meters, then the value of resistance estimated from the graph is. Yeah, when you express the error in percentage, that becomes percentage error, and just if you keep in the form of percentage, thus when you just keep it in the form of fraction, that is fractional error. Let us say if you have 4 by 10 is 2 by 5, so it is a fractional error, you are going to 0.4. 0.4, so you can also express it in this way, 4%, 0.4%. 4% if you write 4 by 100. This is 40%. They basically mean the same, okay. When it is explicitly asking you percentage error, so you will write the answer in percentage. Writing 0.4 and 40% is same. Do this one, guys, quickly. What is the slope of this curve? So from this figure, you know the values here, you know the values here. At V is equals to 25, I is equals to 1. Okay. At 25 volt, I equals to 1 ampere. And at V equals to 0 volt, I is equals to 0 ampere. You do not know other values. We can calculate the slope from this. Do it quickly. कर पाए दोस्तों ये सवाल बहुत ही आसान. So you are given the values of V and I at 0 and 25 volts. So from it we can get the value of the slope. How? To calculate the value of the slope, we need two data points. So two data points we already have, one at the beginning, another at the end. So the slope of the curve, you know, the formula is, let's say, y2 minus y1 divided by x2 minus x1. This is the formula. For here it is I max. So 25 volt and the value is 1. Y1 is 0. X2 is 25. X1 is 0 again. So 1 upon 25. So this is the slope. Value error in the slope. So if I call it m, error in the slope, delta m, okay, or sigma m. Sigma m is how much? 1.255 into 10 to the power minus 3. For the timing, let's ignore the unit. The value of the resistance estimated from the graph. So you know from Ohm's law, V is equals to IR. So R is V by I, right? Now the slope of this curve is delta I by delta V. So you see, I is equals to V by R. So it is like writing m into V, isn't it? But 1 by R is the slope. 1 by R is the slope of IV curve. Okay, and slope we have denoted by m. So m is equals to 1 upon R, and that gives you the value of R to be 1 by m. So 1 by 25, it means 25 ohm. So R we have got. So what we have to measure? We have to measure the value of the resistance estimated from the graph. So R we have got. Now we need to calculate sigma R. What is sigma R? R is equals to V by I if we take. What is sigma R? You can use this relation only. R is equals to 1 by m. What is sigma R? So it is del R by del m square, sigma m square. Can you write it? Now what is del R by del m? Del R by del m, if R is equals to 1 by m, so del R by del m is equals to minus 1 by m square whole to the power 4 sigma m square. So 1 by m to the power 4, 1 by m to the power 4 sigma m square. 1 by m to the power 4 is 1 by r to the power 4 times sigma m square, and hence sigma r, error in measurement, is equals to r square. Have you written anything wrong? Yes, it is r to the power 4 will be in the numerator, right? It is r square sigma m. R square value we know 25. Sigma m value is also given 1.255 10 to the power minus 3. If we calculate this, what much value we are getting? Approximately 0.8 ohm. So the resistance we can write as R plus minus sigma R 25 plus minus 0.8 ohm. Option B is matching. Is it clear to everyone? Anyone has any question, you can ask. आगे बढ़ा जाए दोस्तों, can we move forward? Now this is a question from June 2011. Two parts of this question are given in this way. The resistance is measured by passing currents through it and measuring the resulting voltage drop. If the voltmeter and the ammeter have uncertainties 0.3% and 4% respectively, then the uncertainty in the value of resistances and the uncertainty in the computed value of power dissipated in resistance. Do it quickly. Let's go with the first one. Resistance is measured by passing current through it. So we have to use V is equals to IR formula. Uncertain in the value of resistance we have to calculate. So R is equals to V by I. So you can imagine it in this way, that R is nothing but a function of V and I. So uncertainty in resistance means sigma R you have to calculate. Okay. So it is obviously equals to square root of del R by del V whole square sigma V whole square plus del R by del I square sigma I, isn't it? Voltmeter, ammeter have uncertainty. Voltmeter, what does voltmeter do? It measures voltage. So this is giving to you sigma V. This is given. Ammeter measure current. It gives you the uncertainty in measuring current. 3%. What is the meaning of 3%? 3% means 0.03. 4% means 0.04. Isn't it? So what are you getting? Look, only uncertainties are given. So we do not need to apply this much. We do not need the error propagation formula. We can just simply calculate the percentage, right? You see, if I calculate the uncertainty in the resistance, uncertainty in resistance is delta R by R into 100%. Yeah, uncertainty in the value of resistance is given by this, and this is equals to, look, everything we are calculating in terms of the delta V by V into 100 square plus delta I into I times 100. So this formula is being applied. Percentage, this, look, this is delta V by V, this is the fractional error into 100 means it is given in the form of percentage. Okay, so 3, if you put the value of this is 3, this is in this way it was 25, so 5, and this we have got because 100 multiplied, so we have got in percentage 5%. You don't need to write percent here, but you just check it. Actually, this thing have been applied. Yeah, this one. Here sigma x by x is itself given to be 3%. Okay, sigma y by y is fractional error. You can say the percentage error is given to you, and you have to calculate sigma u by u. So we have actually applied this formula. Clear? Is I not a proportionality constant or a variable? Here we have to treat them as variables. Okay. because both value of V and I deciding R. R is a like a dependent variable. Value of del V and del I is not given separately, it is given in terms of percentage. Okay, you can imagine 3 by 1. So, you can imagine it, this delta V to be 3 and 100 to be V in this way. So, this one we have written incorrectly. Is it clear now? Next, for power, same formula will go, P is equals to V into I. So, error in power equals to delta P by P into 100. So, again delta V by V into 100 square plus delta I by I into 100 square. So, this is again giving you the root of 3 square plus 4 square, so 5. Let us do one calculation, the way we, let us just check whether we are getting alternative thought. Actually, this is the calculation, alternative is not alternative, actually it is the calculation. Let us take R is equals to V by R, V by I, R square V square by I square. Actually, that formula which we have derived, that is the same formula we are being applied here. So, sigma R, so R you can consider as a function of V and I. So, sigma R square del R by del V whole square sigma V square del R by del I square sigma I square. Let us check whether we are getting it or not. So, this is 1 by I whole square sigma V square plus minus V by I square whole square sigma I square. Now, we are just dividing by R square. So, dividing by R square means multiplying by I square by V square. So, sigma R by R square equals to multiplying by I square by V square. So, this is sigma B by V whole square, and this is plus sigma I by I square. Okay. And that is why when you calculate the this is sigma R by R, this is the error in R. Okay. So, we can say error in R in percentage is equals to square root of sigma B by B whole square sigma I by R. Actually, we have used the same formula. Okay. And here it is the uncertainty is given to be 3%. Means if you measure 100 volt, you will get an error of 3 volt. If you measure 100 ampere current, you will get an error of 4 ampere. This is what it is asking now. Yes. Now everything is in percentage. So that is why we have done this. Clear na? चलिए, let's talk about power. This is case 4. It's about powers. So u is equals to, let's say, ax to the power b. Who the, just a moment. Oh guys, too much calls are coming today. Anyways, what is the derivative? So if you are given something in this way, a, b are constants, okay? A, b are constants. So see, the process is same. You have to, here one variable only, x is the variable. So you have to take del u by del x. So if you take del u by del x, what you get? A b x to the power b minus 1. Okay. So we can write it as a x to the power b, okay, into b divided by x to the power minus 1. So x, ax to the power b is u b by x actually. So what is the relative error? Sigma u is equals to del u by del x sigma x, है ना? So u b by x sigma x, and hence del u by u is equals to b times sigma x by x. Okay, this is the relative error or fractional error, you can also say. Relative error in now special cases, or two special cases are there. Special case 1, if let's say b is equals to 1, then del u by u is equals to del x by x, and if b is equals to -1, then what do you have? Actually same thing, just a minus sign. There is no point of this special case. If you have written, just skip it, otherwise you don't need to write it. Let's go for a problem. The viscosity eta of a liquid is given by Poiseuille's formula, eta is equals to pi p a to the power 4 by 8 Lp. Assume that L and V can be measured very accurately, but the pressure P has an RMS error of 1% and the radius A has an independent RMS error of 3%. RMS error of the viscosity is closest to. Can you do this? एक क्वेश्चन यहाँ से मिस हो गया. Look, L and B can be measured very accurately, but the pressure P has an RMS error of 1% and radius A has an independent RMS error of 3%. RMS error of viscosity. So L and V, if they can be measured accurately, so what we can do, we can say that eta is equals to error involved in P and A. So pi by 8 LV we can consider to be a constant. Okay, so k p a to the power 4. There has been no error in case of L and V, so we can consider it in this way. So what will be the error in eta? This will be del eta by del p whole square sigma p square plus del a by del eta by del a whole square sigma a whole square. So del eta by del p whole square, how much? Del eta by del p, just put the values. To make the calculation, simpler, we can do one thing. You see, if we keep k and the information on k is not given, k depends on pi by 8 LV. So let's say we are calculating eta prime. Eta prime is equals to eta by k, that is p a to the power 4. Because look, k is just a scaling factor, k is just a constant multiplied. So error will remain same. If you even if you multiply with a constant, the error will not be a variable. The constant will just be multiplied. Okay, so let's say we are calculating the error in eta prime in the first place, because it is a function of p and a, and the error information about p and a are given only. So this is equals to a to the power 4 square sigma p square plus this one 4 p a cube whole square sigma a whole square. The RMS error of the viscosity. So when we are taking eta prime, we can also just divide by eta prime into 100 whole square sigma p by p into 100 plus 16 4 square 16 sigma a by a into 100 whole square. So we have just divided by eta prime square on both sides and multiplied by 100. We have done on all the terms. Error in pressure P is 1%. So we have written in terms of percentage, so it is 1 square plus 16 into 3%, so 3 square. So 1 plus 144, 145. So approximately we can say 12%. Actually, this is not 12%, this error. Option C, 12%. Few things we have missed. Let's do that. How much we have discussed? We have discussed about powers. Up to powers we have discussed. Let's take the first case. Fifth case, exponentials. We have exponential, then what you gonna do? Let's say u is equals to a to the power bx. This kind of thing is given to you. So what is del u by del x? Is equals to ab e to the power bx. So this is nothing but b into u, and that means sigma u square is equals to del u by del x whole square sigma x square this is equals to b square u square sigma x square. Okay, sigma u is equals to b u sigma x. Okay, if you want to calculate the relative error, sigma u by u, If you want to calculate in percentage, you will into multiply 100, then will do multiply by 100. This is equals to B sigma x. Now let's say if this A is not there. Okay, this is the first case. Acha, the decay constant Fp of a heavy pseudoscalar meson in the heavy quark limit are related to this, and the error values are given to. Take this as homework. Okay, we don't have space to solve, so you will do it at home. Let's take the 5b case. Now instead of this exponential e to the power bx, if it is not exponential, you are given something like this, u is equals to a to the power bx. What you gonna do then? In such a case, what you are going to do? So if it is not given in terms of exponential, you will represent it in terms of exponential. So a can be written as e to the power ln a to the power bx. So this is equals to e to the power b times ln a into x. We can write e to the power, where the c is nothing but b times ln a, and the remaining process is same. You have got e to the power cx, you have got in this in this terms, in this format. So you can write the relative error. What will be the relative error? Relative error sigma u on u is equals to, it will come in this format by taking b is equals to a is equals to 1, b sigma x. Here it will come b sigma x. So you can just put the value back, b ln a sigma x. Simple as that. Let's take the sixth case, logarithms. So these logarithmic cases are many of the times they ask you in the examination. U is equals to a ln bx. So what is the derivative? Del u by del x, if we calculate. So a by bx into b. Can I write it ab by x? Look, a by bx, अच्छा, a ln b plus a ln x. So can I write it ab by x? Tell me, is there anything wrong with this? Actually it will be a by x, right? Sigma square equals to del u by del x whole square sigma x a by x whole square sigma x square. Okay, now is it clear? So logarithms works in this way. Acha, when you have del u is equals to a to the power bx, just another way of doing it. Let's say we have u is equals to e to the power bx. So whenever you see this kind of thing, what you gonna do? You can take logarithm on both sides. And you will be getting bx. Take derivative on both sides with respect to x. So 1 by u, so del u by u is equals to b times del u by u equals to b. Acha, no. If I take derivative with respect to x, it is 1 by u del u by del x. So there is a one variable, so we can write d also, du by dx equals to b. So du b u dx. Achha, are you not getting the same result the way we have got here by, let's say, putting b equals to 1, sigma u is equals to b sigma x. I think this much is enough. Okay, so we have tried to discuss all the types. Now you have understood what you have to do. You will try this problem at home. Fp is equals to a by root over mp. mp and its error is given to you. Fp and its error value is given to you. Error in the estimate of you have to find out. You can use the error propagation formula. Okay. but we will do it at home. With this error propagation and error analysis is over. On the next class, we will be discussing least square fitting. Least square fitting. This is also very important topic. Question may come in 5 marks, and very simple. We will take different cases of least square fitting, and after that electronics will be over. Okay, so we are stopping here, guys. Thank you, guys. Thank you very much for joining the session. I hope you find this session useful, and see you guys in the next class. Bye bye. Take care.